We are starting with a new module, and the module is chapter D. In that, the first topic we are studying is D1, which is Surds and Indices. It's a pretty simple, straightforward formula-based topics. All you have to know is the different formulae for different types of expressions and some bit of solving practice so as to make things easier for you. And this D module is also in continuation of the main broader classification of number theory. So let's start with surds and indices. The first and foremost part is the introduction. What is the power and what is the base? So when we say 5 cube, what really we mean is we are multiplying 5 with itself 3 times. And 5 is called as the base and the power is called as the index. This is the introduction. The first part, the first formula, a raised to m into a raised to n. Remember this, whenever the base is same and powers, there is a multiplication, powers are always added. So we will get a raised to m plus n. Same has to be applied for the second one, a raised to m into a raised to n into a raised to p, a raised to m plus n plus p. Third one, a raised to m upon a raised to n. Multiplication may we add, division may we will subtract the powers. A raised to m minus n. A raised to m the whole raised to n, powers will be multiplied, we will get a raised to mn. Fifth one, nth root of a is a raised to 1 by n. Sixth one, nth root of a raised to p, a raised to p by n. A raised to minus n is 1 upon a raised to n. A raised to 0 is 1. Anything raised to 0 is 1 provided the base is not equal to 0. The particular thing about these formula is that formula number 5 and 6, wherein which we have the fractional power. Whenever the power is a fractional power, they are called as surds. So remember that. Next formula, a into b the whole raised to m, obviously, and a upon b the whole raised to m. The power m has to be distributed to both of the terms. So a raised to m into b raised to m and a raised to m upon b raised to m. But some few more properties of indices. If a raised to m is equal to a raised to n, then if powers are if the bases are same, and there is a equal to sign in between, the powers has to be same, but there are some 3 specific values of a for which this may not be true. Except those 3 specific values, this will always be true. So m is equal to n, the powers will have to be equal as long as a is not equal to -1, 0 and +1. The second one, a raised to m is equal to b raised to m. Then there will be 2 cases. A is equal to b if m is odd, and a is equal to plus or minus b if m is even. The example for this is, suppose a cube is 5 cube, so a turns out to be positive 5, and a cube is minus 5 cube, a turns out to be minus 5. So whenever the power is odd, a is equal to b. But for even powers, it may not be the same because a square is 5 square. So a can be either plus or minus 5. So for even powers, we'll always have 2 scenarios, positive as well as negative. Next part, the third property, wherein which we are supposed to compare both the expression a raised to m the whole raised to n on the left side, and on the right side a raised to m raised to n. So the answer to this comparison is, we cannot just by looking at the expression figure out the values and compare the two things. We need all 3 values of a, m and n for figuring out the answer. So it all depends on the values of a, m and n. Basically all 3 conclusions are possible. We have examples for that as well. Just say if the numbers are like that, so left side becomes 2 raised to 6, whereas on the right side we'll first need to simplify 2 cube, which is 8. So right side becomes 2 raised to 8, and obviously 2 raised to 8 is bigger than 2 raised to 6. Similarly, if the numbers are in decimal, the answer reverses. 0.5 raised to 6 on the left side and 0.5 raised to 8 on the right side. So 0.5 raised to 6 is bigger than 0.5 raised to 8. And for all you know, if numbers turns out to be like that, then both the left and right side will be equal. Both will have 3 raised to 4. So all three results are possible. So hence we are saying that just by looking at the expression, we won't be able to compare. We would require all the three values of a, m, and n. Then after this, there is something called as rationalization. Rationalization is nothing but multiplying by the conjugate on both numerator and denominator. Conjugate sounds like a fancy word. All you have to do is change the sign. So if this is the surd, 8 upon root 5 plus root 3, the conjugate of that is root 5 minus root 3. So we'll multiply by root 5 minus root 3 on both numerator and denominator. In the denominator, I hope you can see that you have a plus b and a minus b, which is a square minus b square, the formula, algebraic formula from C3 operations on numbers. Then that gives you 5 minus 3, which is 2 in the denominator. In the denominator you have 2, in the numerator you have 8, that gets reduced. 2 4s are 8, and you get 4 root 5 minus 4 root 3. This entire process by multiplying the conjugate in both numerator and denominator is called as rationalization. So this is what you need to remember.
So first question, x raised to 9 is equal to 9 raised to 9 raised to 9. Then find the value of x. Now to solve this question, the first step that you should do is on that right side, get rid of that scary power. So 9 raised to 9, let that be equal to m. So now your question is x raised to 9 is equal to 9 raised to m, which is a bit little less scary. Now, because we were supposed to find out the value of x, that means we need to get rid of x raised to 9. So that means we need to take the ninth root. If we take the ninth root on left side, that also means we should take the ninth root on right side as well. So ninth root of 9 raised to m, and the formula that we'll be using is nth root of a raised to p. When we do that, the value x is equal to turns out to be 9 raised to m by 9. So nth root of a raised to p formula is a raised to p by n. Now what you will do after this is substitute the value of m, which is 9 raised to 9, and after this we'll use the division wala formula. Whenever the base is same, powers will be subtracted. So that gives us 9 raised to 9 minus 1, which is 9 raised to 8. So the value of x and the final answer of this question is x is equal to 9 raised to 9 raised to 8, which is first option. Second one, arrange the following numbers in the ascending order. So simply you are going to use the formula of nth root of a. When you do that, nth root of a is a raised to 1 by n. So square root of 2 will become 2 raised to 1 by 2. Cube root of 3 will become 3 raised to 1 by 3. And sixth root of 6 will become 6 raised to 1 by 6. Now, obviously, there is no way you can find out the fractional powers. So what you'll do is convert them to proper powers. And to convert them to proper powers, what you will have to do is take the LCM. When you take the LCM, the answer for 236, the LCM is 6. So let's make every number raised to 6. Now after that, which rule we'll be applying? We'll be applying a raised to m, the whole raised to n, and the powers will be multiplied to each other. So we'll get a raised to mn. So 2 raised to 1 by 2 into 6 will be 2 raised to 3, 3 raised to 2, and 6 raised to 1 respectively. Now we can easily find out the values. 2 cube is 8, 3 square is 9, and 6 raised to 1 is 6. We were supposed to arrange them in the ascending order. 6 will be the first one, 8 will be the second one, and 9 will be the third one. So that means sixth root of 6 is the first number, followed by square root of 2, followed by cube root of 3. That is the ascending order. Third one, simplify the following expression. Now don't get scared with this. Just consider the first number and we'll use rationalization. So rationalization is multiplying both the numerator and denominator with the conjugate. So root 9 plus root 8 ka conjugate will be root 9 minus root 8. So when you do that in both numerator and denominator, in the denominator you will have a plus b and a minus b. So a plus b and a minus b, the answer will be a square minus b square, which will be 9 minus 8, which is 1. So that means only in the numerator you will be left with the conjugate, which is root 9 minus root 8. Similarly, when you apply that to the other terms, because the numbers are consecutive, all the terms will have the denominator part as 1 respectively. So that means their respective conjugate is only thing that will be left in the numerator. And now because we are supposed to add them, again what will happen, the alternate pluses and minuses will cancel out each other. So that will give you the answer as root 9 minus root 4, that is 3 minus 2, which is 1. Find the square root of 7 plus 2 root 12. So here we need to remember the formula of root a plus root b the whole square. So root a plus root b the whole square will be, that is a plus b the whole square, that is a plus 2 root ab plus b. And now that trigger 2 root ab is what you are supposed to understand. So 2 root 12 is your 2 root ab, yani ab is 12, yani product of two numbers is 12, and the sum of same two numbers, that is a plus b, is has to be 7. So we are looking at such two numbers whose sum is 7 and whose product is 12. So only one pair which satisfies this, which is 3 and 4. So a and b is 3 and 4 respectively. So root 3 plus root 4 the whole square, when you expand, you will get 7 plus 2 root 12. But if you remember, we were supposed to find out the square root of that. And when we find out the square root of that, we'll have to also take the square root on the left hand side. So on the left hand side, when you take the square root, square and square root will get cancelled and you will be left with root 3 plus root 4. Fifth one, if PQR is equal to 1, then the value of this expression. So the idea here is you will see that there is a pattern that is repeated, which is all the numerators are 1, all the denominators has a very specific thing, that is 1 plus some variable and inverse of some other variable continuously, that is happening one by one for each of the variables of PQR respectively. And there is a plus in between. And whatever this pattern that is repeating, if such is the case, then they are called as cyclic expression. So remember, students, that whenever such is the case, that whichever may be the pattern, it may not be the same exactly, but as long as it is the same pattern repeating everywhere, it is always called as a cyclic expression. And the beauty of cyclic expressions is that their sum is always 1. So the value of this expression will not be dependent on the values of PQR. PQR can be anything, can be fractions, can be positive numbers, can be negative numbers, can be anything literally. But the sum of these expressions will always be 1 because they are cyclic expressions. Example, PQR sum product of three numbers is 1. The simplest possible assumption that all of them is 1. And when you substitute all of them as 1, you would get the answer as 1 because each of the term becomes 1 by 3. 1 by 3 added 3 times will give you 1. But you don't have to do this. This is just for the representation purpose. Main underlying idea is the cyclic expression concept and the trigger to remember that. Next one, three numbers are equal to each other. We have to find the value of some expression. Similar kind of a thing we would have explored in ratio proportion. Let all of them is equal to k. Individually also they are equal to k. So the value of 3 in terms of k will be k raised to 1 by 2x. For 4 it will be k raised to 1 by 6y, and for 12 it will be k raised to minus 1 by 3z. Ironically, when you observe, now this is like pure observation, on the left side when you multiply the first two numbers 3 and 4, you get the third one, that is 12. Same thing should happen on the right side. So k raised to 1 by 2x into k raised to 1 by 6y will give you k raised to minus 1 by 3z. Laws of indices, base is same, and whenever there is multiplication in between, the powers are supposed to be added. Then we'll shift that k raised to minus 1 by 3z on the right side, it will become plus, and the entire thing is equal to 0. Cancel out kk from both the ends. Later on, what we will do, if you remember the value that we were supposed to find out, 1 upon 2x plus 1 upon 6y plus 1 upon 3z, we have just now figured out that value, entire thing is 0. And that means the final answer will be 0 plus 5. Answer is 5. Option 3. Seventh one, 4 raised to x plus 5 minus 4 raised to x plus 4 is equal to 3. Find the value of x. 2, 3 approaches are there. One is you substitute the value of x from the option, check which value satisfies, you get your answer. Second way, you actually simplify this expression and then find out the answer. Third one is a smart option that I'm going to discuss. When you observe the power x plus 5 and x plus 4, what you end up realizing is that they are two consecutive powers of 4. When you observe the powers x plus 5 and x plus 4, what you observe that they are the two consecutive powers of 4, back to back powers of 4, and their value difference is 3. When you think from that perspective, which consecutive powers of 4 has a value difference of 3? So it is 4 raised to 1, which is 4, and 4 raised to 0, which is 1, and 4 minus 1 will be 3. So that effectively tells me that in the place of x plus 5, it should have been 1, so that it becomes 4 raised to 1. And in the place of x plus 4, it should have been 0, so that 4 raised to 0 is 0. Sorry, 4 raised to 0 is 1, and 4 minus 1 is 3. So you solve for that, either x plus 5 is equal to 1 or x plus 4 is equal to 0. Both the expressions, after solving, you will get the value of x as minus 4, which is answer option 5. So the two consecutive values of, sorry, powers of 4, and the difference of the value between them is 3. 4 raised to 1, 4 raised to 0. Answer option 5. So x is minus 4. So we are done with this. If you have any questions, let us know. Thank you so much.